presentation, but it needs some time to open the presentation. Now it's there. So the floor is yours.
Thank you. I'm Kai-Fung. I was a future fellow. I finished the future fellowship, and then I moved to the University of Bristol to continue my research on AI. Especially the job title is lecturer in AI. So I've been working on AI for the last 10 years. I still remember I start my PhD in 2016, and then it's 2026 now. So literally 10 years. I've been working on various aspects in AI, and from optimization, machine learning, reinforcement learning, and then especially I also want to thank you for the future fellowship that I can have the chance to work on robotics. So it's really quite broad area in the AI, and my interest is related to the transportation. And so this presentation actually is not like the single project presentation. It's really a summary, I would say, of of my opinion or perspective on AI in transportation. So as I mentioned, I work in various aspects, not just the technology, but also in different transportation sector, I would say, like the autonomous vehicle is the starting point, and the relationship or the interaction between autonomous vehicles and human-driven vehicles, and also vehicular communications, how to predict or model the traffic data and predict them, and also to control the traffic light to improve the efficiency. There's one crazy idea on whether we can dynamically reverse the direction of the lane if the driver on the lane are crazy enough to adapt to the directions. And also looking forward to the electric vehicles, there's also a concept called vehicle to grid, and how to leverage the large battery in the electric vehicles is something that I was quite interested in a few years ago. And also the mobility as a service is another concept that unify different transport operator, and also the cybersecurity issue in it. So it's, I have been working on different sectors, and also with different technology, as I mentioned, optimization, machine learning, robotics, etc. And then I feel that once I finish one topic, then I start to hate that topic, and then I move on to the next one. I wonder why I doing this, and then so the option one is that this is my personality. I love new stuff, or sometimes later I understand that maybe this is because of the famous low free lunch theorem. So it just essentially say that there's no free lunch. That means no one single technology or method can be the best for all applications. So that's why I keep changing from different different sector, different technology. And then, especially for this visual conference, it's really a nice place for me to summarize most of my research and finding, especially my idea on the future role. I mean, the future role. And what I envision the future is that there will be many free components that leverage the computational intelligence, embodied intelligence, and also the collective intelligence. Focusing on the information layer, physical layer, and also the coordination layer. And I'll explain it bit by bit, but this is overall architecture that I think different pieces needs to be filled before we have a very mature transportation systems. So for first one is the computational intelligence. Well, this focus on the like the brain, like we have lots of AI, like the ChatGPT, LLM kind of AI that stayed in the digital world. They didn't really interact with the physical world, and I will leave the physical part in a bit. But this digital world itself is already a very complex problem. There are lots of things to solve, and well, first of all, it's stand as the information foundation of future roles. Like one example is how to predict the traffic data and to predict and model the traffic data, because traffic itself is a very complex dynamics. So people are leveraging, say, machine learning, mathematical techniques to model it. And I think this is definitely one of the area that people should devote their efforts to solve the computational problems. Like the previous presentation, Yui did a lot of optimization, solve the optimization problem, routing problem. That's excellent. One of the example that I did before is the traffic forecasting, and it's literally try to forecast the future passenger demand in the city, and then by dividing it into several grid cells and make use of the machine learning, deep learning techniques. And I remember this is like about 2018 when those LLM are still not exist or popular. That I make use of the convolutional LSTM to predict both the spatial and temporal correlation of the data. But one more step is the granular correlation, which is to divide the city into different resolutions so that you can make use of the easy prediction, the first layer, because it's easy. If this whole city, you can more or less guess the demand. But if I ask you, okay, what's the demand of particular building, it will be super difficult. So we make use of the relatively accurate prediction to inform the harder problem. So that's why the information flow from the first layer to the next layer. So that's one example. And then for the embodied intelligence is something that really interact with the physical world, because transportation obviously is embodied, not just staying in the digital world. So it's the physical layer of the future worlds. And as I mentioned, yes, interact with the physical dynamics, the vehicles, infrastructure, and the environment. So what I envision this layer is that it can enable a very efficient autonomy and physically aligned autonomous control. So another example is to make use of the traffic as a computer. And I won't go through the details because again, this is a very summary of 10 years of research. So we can talk a bit more later on, but essentially we build this car and use them as a computer to predict some, to solve some computation problems, which make use of the physics of the traffic itself. And I will go into the details because of time limitation. And the third layer, and also the last layer, is the collective intelligence. And you know, there are lots of agents on the road, like the vehicles, infrastructure, etc. So they have to coordinate. They, even though you have the computational intelligence and also embodied intelligence, if they're not coordinating, we cannot have a good transportation system. So here it's all about coordination in the future world, and especially in a relatively higher layer, like in the network scale or city scale. And transportation network itself is a good example of this high level scaling up, having this scaling up properties from individual vehicles to network traffic. And here, the collective intelligence can enable scalable and resilient network level behavior. So another example is that on how to rewire a graph, and here I just use a normal graph to mimic maybe, let's say, the transportation network, and to study whether we can achieve cluster synchronization. Well, synchronization means the state of each node are the same, so they kind of converge to the same state by rewiring the edge. So you can imagine in transportation, it will be like rewiring the road, for example. So we make use of reinforcement learning to learn the optimal rewiring policy to do that. So this conclusion. So well, again, this is really a very quick overview summary of this multi-layer intelligent architecture, and I think this is really needed in the future world. And and this is more on the future work. As I mentioned, I did things one by one, I mean part by part, but I haven't really explored the synergy between them. Like, can we explore computation intelligence with embodied intelligence or other combination? I think that is something really excite me, and that is something I will continue on my faculty position at the University of Bristol. And that's the end of my presentation. Feel free to let me know if you have any questions.
Yes.